Now that we are good with solving systems of equations for two variables, let's throw in a third. This is going to be overwhelming at first. It's going to be a lot of steps. But once you have mastered the substitution and the addition method, or we call it the elimination method, either one, then you can do this 3 variables easy, and then maybe I'll give you a little shortcut. All right, so like I said, we're going to have 3 variables. That means we're going to have 3 equations. So here is an example showing you we've got our 3 equations, and we got x, y, and z, and we need to solve for all 3 of those. So step 1, we are going to use our addition method on the first and second equation. Okay, so you might want to write this down. So the point of doing this is to eliminate one of your variables so that at the end we have only 2. So let me label these equations 1, 2, and 3. So we're going to do the addition method on the first one and second one. So there's my 2 equations, and nothing sadly eliminates easy. So I'm going to have to multiply one of them by a number so that they will eliminate whenever I add them together. So we have the y's with the same number, but since they're not the same sign, they're not going to, -3 minus 3 is going to give me another negative number, and we're not going to get rid of those y's. So I need to make one of those 3's positive. If I take a negative number, how do I make it a positive? I multiply by another negative, right? Because negative times negative equals positive. So I can multiply this first equation by -1, and that would give me a positive 3, and that will eliminate my y's. So -1. Remember. You have to multiply that -1 by each term in that equation. So -2 times -1 is positive 2x. -3 times -1 is positive 3. Positive 3 times -1 is -3. -4 times -1 gives me positive 4. Okay, so that's our new equation. Hold on to that equation because we're going to move on to step number 2. Oh, step number 2. We're still on step number 1, guys. We have to add them now. Add them so that we are left with two variables. We're not done. Okay, so 2x plus 5x equals 7x. 3y minus 3y, no y, gone. -3z plus 5z is 2z equals 4 plus 8 of 12. So now we have an equation with only 2 variables, and we know what to do with that in just a minute. This is the equation to hold on to. Let's move on to step number 2. Now we're going to use our addition method on the second and third to eliminate the same variable. So we chose to eliminate y in the first step. We're going to eliminate y in the second step. So let's name our equations again. So we're going to use number 2 and number 3, and we're going to eliminate the y's. Well, look at our equations. -3y plus 3y, that's 0y. So we don't have to do any multiplying. Yay! We can just add our equations. So 4x plus 5x is 9x. 5z minus 2z is 3z. And 8 plus 7 is 15. So here's our new equation. So we held on to that other equation. And this is our other new equation. And we are going to use those 2 new equations, and we're going to solve them using either the addition method or the substitution method, whichever one you like better. So these are our 2 equations that we created, and we're going to solve those for x and z. So I'm going to use the substitution method here. I'm going to take that second equation and I'm going to solve it for z. So when I do all my math, which if you're still getting tripped up on, just ask me. All right. So z equals -3x plus 5. So remember substitution? Once we solve that equation for one of the variables, we substitute that into the other equation. So I'm taking 7x plus 2 times that whole equation that we found equals 12, and then I'm going to solve for my x. So distribute your 2 to both terms. Remember both terms. So negative 6x plus 10. Remember to multiply by both terms. And combining like terms, x plus 10 equals 12. Subtract 10 from both sides. X equals 2. Now we need to find z. So I can take that z equals and plug my new x into where x is. Substitution. Remember, substituting is when you replace something with something else. So I'm replacing that x variable with the number 2. So then I no longer in this equation have the x variable. So z equals negative 3 times 2 plus 5. When I do the math, z equals negative 1. So let's take that information and move on to step number 4. We're going to plug both of those variable numbers, the x and the z that we found, into whatever your choice original equation to solve for that third variable. So we found x equals 2, z is negative 1. So I just chose the first one because it's the first one. So I plugged in 2 where I saw my x, and I plugged in negative 1 where I saw my z, and then y is our variable, and we know how to solve for that. Negative 2 times 2 is 4. Negative 3 times negative 1 is negative 3. So it's negative 4 minus 3y minus 3 equals negative 4. Combine my like terms, which is my numbers. So negative 3 minus 3 is negative 7. So now I need to work on getting y on the left-hand side by itself. Right now it's being multiplied and then subtracted. So let's do the opposite. Opposite of subtraction is adding. So add 7 to both sides. I don't know why that's popping up in the wrong order. When I add 7 to both sides, then I'm left with negative 3y equals 3. And then I divide negative 3 on both sides, and y equals negative 1. Okay, always check your answers. So choose another one of those equations, any of the other two, so 2 or 3, and plug in your x, your y, and your z. So any of the other two. So we got x, and we got y, and we got z. And when we plug it in, I just chose the second one because it's the second one. No rhyme or reason. So where I saw my x, I plugged in 2. Where I saw my y, I plugged in negative 1. Where I saw my z, I plugged in negative 1. And if that equals 8, then this is our answer. So once I do all that math, 8 equals 8. Yes, it does. So it checks out. These are our answers. This is our x, y, and z. This is it. We solved for all 3 variables. You also see it written like this, in order, x, y, and z. Don't mess up the order. Put your x first, y, z. Just how it is, okay? So let me know if you have any questions solving for 3 variables. Once you guys try to do all that work on your own, I'll give you a little shortcut.